welcome back again. I just answered, so we are going to redo the webinar right now. We had a few technical difficulties, obviously trying to figure out a few things, so I do apologize for this. Crystal and I are working very hard to make sure you have a good product. So anyway, let's get started on this. This is the second presentation in a series of 5 webinars for the DBA Madness presented by Pragmatic Works. And I am Michael Wall, one of their consultants. If you were in my last presentation, you may have seen this screen before. I am a senior database administrator, and I've worked on a lot of things. I actually started off my life doing PC support, and I was a Unix administrator, and I then moved into doing Oracle support. I've done a lot of SQL Server report. I've worked on Ingress, which is a lesser known database engine, but still just as viable. I've also worked on a lot of different OS platforms. I've worked on Windows, Unix, VMS, which is our VAXs for the older people like me who remember what VAXs are, and now our modern platform, Azure, which is what we're going to be talking about today. I am a local SQL Server user group leader and a regional supporter. I'm not feeling like I'm doing very good support right now due to the coronavirus. I had to cancel a couple conferences, or they got canceled out from underneath me, but unable to go out there and speak in public like I love doing to all the people. Just gonna have to step up on the webinars and just do this whole remote work thing. Addition to that, the SQL Saturday presenter, these are the conferences that got canceled. And big on community. If you look around on blogs about how to be successful as a DBA, a lot of them are gonna point to join a user group, get out there, be active. I can't stress this enough. I really got myself into it probably about 4 years ago, and it's really changed my perspective on how I feel about my job, my career, and I've met some really nice people. I just believe that you can feel a lot better about what you're doing, and it's nice to go talk to these people. And as putting on my speaker hat, I can tell you that user group leaders are always looking for people who are willing to speak on any sort of topic. Go talk to them. It's a great, safe environment where you can talk about a variety of topics, and you can do as little as 5 minutes, you can do up to an hour, 75 minutes. But the point is, get out there, get your feet wet, and the best thing for you, in addition to meeting all these nice people, is that you are going to force yourself outside of your comfort zone, and you're going to be learning some new things. You're going to go really deep on a couple topics, and that's going to make you a better person. Azure, and this whole presentation right here, is based on some challenges that I had at a work site, and I turned it into an opportunity about learning about Azure and Azure Performance Tuning, because I was wondering, why isn't this working the way it should be? And there we go. So anyway, welcome to the cloud. And my apologies. There we go. Prior planning and preparation prevents piss poor performance, attributed Phil Campion. This is also, I believe this is the motto of the UK's SAS. This can be not just military things, this applies to anything. I think that any of you in IT have probably been on a project or 2 or 3, and you've seen good projects and you've seen bad projects. And as always, if you spend the time to plan and prepare for what you're going to do, it's going to be a better outcome. It's not always going to be a desirable outcome. It's not always going to make people happy, but at least you can say that you did a good job preparing for the event. And this ties into going to the cloud. Is not as straightforward as it might seem. Former boss of mine used to talk about rainbows and sunshine. Really, it's more of the other analogy used, which was building the parachute after the bus has gone off the cliff. In my past experiences and even current experiences, there's a lot of got-yous in the cloud. There's a lot of knowledge out there. It's still a great place. I think that there's too many different options, and I think that gets kind of scary for people. But unfortunately, it's not just as simple as moving to the cloud. Specifically in this presentation, we're going to be talking about restoring a VM, a virtualized machine, from your environment into an Azure space. We whether it be the process of if you still have on-prem services in your data center, you have a local data center, you may have already virtualized. If not, we're not going to talk about how to virtualize. But the main point is that you're going to take some virtualized machine, whether it be from your local on-prem servers or maybe a local data center, and move forward from there and restoring it into your Azure space. As I stressed in my last presentation, I'm going to continue stressing this one as well, this is a great opportunity to work with a business. Most likely, your database is going to have an application on the front end of it, and that application's performance is going to be very important to your customers. So this is a very good time to work with a business, identify what the desired outcome is going to be, what's going to be the expected performance levels, and also discuss the cost. We're not going to go down into great detail about the cost, but you need to be aware that it's very easy to spend a lot of money in Azure, and it's also easy enough to not spend as much money in Azure. But if you're aware of what you're getting into, you're going to be better for it. There's a lot, as I said, there's a lot of information out there. There's also a lot of documentation. And my goal here is to make you aware of some better paths that you could take, but also so that you're not scared and maybe you don't have to do quite as much work. So read through the documentation and learn and just do a better job. So the good place to start is the Azure Pricing Calculator. It's the link is right here, and what it's going to show you is it's going to let you set up the estimated cost for the VMs that you want to build. As you can see right here, one of the things they're going to show you is they're going to show you here that you have the number of CPUs, the number of RAM. Simple as that, just a computer. It's going to give you an estimated cost. Also, the really important thing that your infrastructure team probably will have already set up for you anyway is think about the region. I happen to live on the West Coast, so I tend to build my Azure servers for my own purposes on the either West US or the West US 2 data centers. So these are referring to regions. An Azure region is an area that has at least 3 or more data centers, and you're guaranteed that you're going to have service in that region. In addition, here you can see the name of, you can see the type of instance you're going to be getting to. But the pricing calculator is just one way to look at it. I personally think the better point is to look at the actual virtual machine sizes, because the pricing calculator has some fairly high level details, but you need to specify what you're looking at it for. So the basics, the computer. Compute is the recognized standard term in the industry in cloud for the actual computer. You're talking about a virtualized machine, and you're going to have choices on the CPUs are going to be in there, the RAM, and a lot of other different features. As you can see right here, we have a link on the Microsoft Docs in order to go look at the sizes for the virtual machines. I think at last time I checked, there's about 250 different options, and they range from the very, very tiny, the A class, all the way up to the huge classes. Microsoft has made it possible for you to virtualize or to port almost any size of server from your environment up into the cloud without issues. As we look right here, so here's a list. Specifically, we're going to be talking about this class of server right here, the DSV3s, and then also the ESV3s for some reasons that we'll talk about a little bit further down in the presentation. As you can see right here, we have the CPUs, we have the memory, the temp storage drive, which is very important, max data disk. This is also very important, especially depending on what you have to. Sorry, we have a cat scratching on something. And then also the network cards. Very important to have all this. So throughput, you may see this category right here on the max cached temp storage throughput and the max uncached disk throughput. We're going to be talking a lot about that in the 5th webinar. coming up here at the end of the month on the 31st of March. Really important stuff. We are going to touch on this. You're going to hear me talk about the 5th webinar quite a few times, because we're going to really dive deep into the details about what makes the storage layer in Azure and what are some of the gotchas in that, because you need to be aware of the throughput issues in Azure. But in the meantime, we're still going to be talking about the server. So you come here, you look at your server, you analyze what you have in your current production server, and then you come here and you pick out a server based on what's going to meet the needs of your users. As I said, I mentioned the DSv3 and the ESv3 models. One of the main reasons I'm mentioning these is because of the storage options. They're not horribly priced servers. They have a lot of flexible storage options, and more importantly, they support the new Ultra disks. This is really important because the Ultra disks are Microsoft's latest offering and it's the superior storage model, but it's also very expensive. And I think it's important to realize in these servers is that they come with a dedicated temporary SSD. So that SSD is very important, and we're going to be talking about that. As you can see right here, each one of them comes with it. So you have to imagine that in an Azure data center, wherever that might be, they're all over the globe. Remember, they're not actually in the cloud, they're on the ground, they're in data centers. And there are racks of servers. And each one of these servers has, as specified here, a certain number of CPUs, a certain amount of memory. But the unique thing about the temp storage SSD is that disk drive is actually connected directly to the server itself. All the rest of your storage is coming across the network. It's going to be in a huge attached storage device. It may be close locally, but there will still be some latency because it's not connected directly to the backplane, to the motherboard. This temp storage is important specifically for the people who are watching this presentation, because all of you are probably database administrators or working with SQL Server. As you may know, SQL Server has a Tempdb. Incredibly important part of SQL Server. It's the part that does a lot of the processing. And because of that, you always want Tempdb to have the very fastest storage options. You don't want to have any sort of bottlenecks there. Because if you do, the rest of the database is going to be in pain. And you have to remember that you have one single Tempdb for all of the databases on your SQL Server instance. So it's incredibly important. I mean, it could be a bottleneck for one database or 20 databases or even 50 databases. So you always want to allocate the best performance you can. One of the things to remember is that the SQL Server Layout is that the best practices that you may have learned 20 years ago still apply. In these VMs, you want to make sure the data is on its own drive. You want to put your logs on another drive, and then finally temp on its own drive as well. So going back to this data, so you're talking about your asynchronous IOs. That is going to be 95% of the transactions in your database. So you put it on its own drive. Logs and backups, those are both synchronous. You want to have a different type of drive set up appropriately for doing that sort of stuff. And then finally, you have Tempdb. Tempdb has its own needs and demands. Again, put it on its own drive. We're talking again about this Tempdb installation. So as we talk about the Tempdb on this drive, I'm not sure how many people in the audience have used PowerShell before. I highly recommend that you get involved using PowerShell. PowerShell has been transformative for the database administrators. Automation has been a big key point of most administration. Automation affects all of IT, and database administrators are no different. Excuse me. Due to this, so learn PowerShell. I've been using it off and on for about 8 years now, and it's always challenging, but it's always great to use. And I'm also going to recommend this package of Dba Tools. Dba Tools was written by Chrissy Lemaire, and thousands of hours by all the community supporters. Lots of great people out there in the SQL community have contributed to make this a useful package. This is a free package that has mostly every possible scenario you could think of that you want to do with SQL Server administration. As I've got the link right here. So the reason why I'm mentioning this is that we have this Tempdb. So it is we go back here. It is a temporary drive. Let's go back here to this screen right here, temp storage. This drive, none of the storage on this drive is guaranteed to be persistent after a reboot of the VM. Because of that, you would not want to put any sort of important files. But Tempdb is recreated every single time that you restart SQL Server, so that's okay. So why do we need to worry about PowerShell? Why do we need to worry about Dba Tools? Because what we want to do is this general process, and as I've said here in the slide, and I promise you that I will probably write up a short webinar in order to show the process, or we'll post it on the blog. Essentially, the process you're going to be doing is that when the server is restarted, the way that I do it is I go into Windows Scheduled Tasks, set up a task that on creation, on reboot of the server, it runs PowerShell. It looks at that drive. It sees if there's anything on there. If there's not anything on there, it goes ahead and creates the Tempdb folders. And then it tells SQL Server to come online and create your Tempdb data files and data and log files in that folder. After that, it goes ahead and tells SQL Server to restart. And at that point, your database is up and running. Now, this may sound like a lot of steps, but in reality, it probably takes about 5 seconds to do. So again, the concept of recreating that Tempdb every time. Why is this important? Because in my experience with Azure VMs, even if you're using premium SSDs, I found that the latency was horrible on there for Tempdb. I was seeing something like 5,000 milliseconds. Because of that, I went and started using this method of the Tempdb, and it went down to under 500. It still wasn't perfect, and that's why I think the ultra drives are so important. But this drive comes with your VM. You're paying for it. Go ahead and use it. It's a great opportunity. It's going to really improve performance on your high transaction servers. So finally getting to the point about what you're getting into. So you are paying for a service, and Microsoft or any other cloud provider is only to give you what you paid for. Due to this, we're going to talk about basic storage concepts a little bit. Here again, once again, I'm going to mention the 5th webinar, which is where we really are going to talk about the storage concepts. But I think it's important that you understand the basic offerings that come with a VM. You're probably working with an infrastructure team, and they're going to be the ones who are going to set up your Azure VM for you. But I think it's incredibly important as DBAs for you to understand the underlying OSs. The days of just being a DBA where you just deal with a database are long gone. I think that if you want to be a modern data platform expert, you need to understand the OSs. You need to understand all the different bottlenecks that affect your database. You need to understand some networking too. All of these are important in order to create the complete DBA package. Along those lines, I don't think that you actually need to have the ability to create your VMs unless your business supports that. But you do need to have read-only access. You need to have access to the Azure portal. In writing this webinar, I realized that there's yet another wonderful webinar to be coming about talking about using the Azure portal and, more importantly, Azure Monitor. One of the things that you're going to run into, you're going to want to be able to take advantage of all of the built-in features that comes with Azure. And Microsoft has done a great job in giving you these built-in monitoring tools that they're just constantly watching all of your servers for 30, you have 30 days worth of data right there. It's always available. There's nothing wrong with using perfmon, nothing wrong with using extended events. All those are still there, and you should probably use those. But the difference is that you've also got these free tools that, no, not free, but anyway, you're paying for it, but these tools are there. Go ahead and use them. But again, the reason I want you to understand this is because I don't want you and your users to have this experience right here. Because you've moved your server up into Azure, everything's supposed to be wonderful, and then everyone's like, well, what happened to my application? As we do talking, so let's move into storage options in Azure. There's a lot to think about here, even without getting into the issues of the performance characteristics. And right here, I've got the link here to talk about the different disk types. Take a look. You can see what the different, you can get an idea of the prices and some of the characteristics of each kind of the disks. Managed versus unmanaged storage. This is a little bit confusing. Microsoft wants you to do managed storage. There's nothing wrong with unmanaged storage. Unmanaged storage was the way it was until they released managed storage about 2017, I think it was. Managed storage is easier as a DBA to keep track of it. Unmanaged storage is where you have a storage account and then you have your different disks inside of it. Managed storage is where you actually see the individual disks. So as I break down the differences here, the prices are exactly the same. You have all the same storage options within it, and I'm talking about the types of disks. Performance is the same. Security is where it really starts to differ. So managed disks allow you to have a role-based access control, RBAC at a disk level. So in unmanaged storage, you have access to you can only be granted access to the storage account, which means that anyone can be granted access to that storage account. In managed storage, that means you can get much more granular. That's very important for a managed environment. You don't want everyone to have access to the drives because that means that someone could do something like delete the drive. So allowing your administrators to set that security is incredibly important. Availability. Managed disks are automatically integrated into availability sets. We'll be talking about that a little bit in the future. Managed disks are also automatically encrypted. And then finally, as I just alluded to also, the Azure Monitor. We're going to be covering that in future webinars. The Azure Monitor is that built-in tool, and it's a lot easier to see the performance when you're looking through Azure Monitor on managed storage. Standard versus premium storage. There's 4 different levels of storage, each with its own limitations and costs. So you have your standard HDDs, hard disk drives, the rotational disks. They exist for a purpose. They're meant to be there for your long-term storage, your backups, things that you're not so worried about. But be mindful, even though that they're cheaper, they also charge you per the transaction. So if you wanted to go to this option, and note it is a lot slower, because I believe that they're mentioning something like, I believe the guarantee is something like 20 millisecond latency time as compared to 2 for the higher performance storage. So they're slower, they are cheaper, but if you were to do a lot of accessing on these drives, you're going to end up paying for it in the transactional costs as compared to, you're going to lose that cost savings by going with the cheaper disks. Standard SSD. Using SSD, slightly more expensive, lower latency, better performance overall. These are probably going to be good for most customers. They'll probably do just fine for basic needs. But as database administrators and any sort of high-end SQL Server installation or even a low-end SQL Server installation, I'm going to push that you should go to premium SSD. They're more expensive. There's no question. And we're not talking about a huge amount, but they are definitely more expensive, but guaranteed lower latency. And now something kind of neat is they got the new bursting technology. So again, 5th webinar, we're going to talk more about the performance characteristics of the disks. But the important thing to remember here is that you are capped on how many IOPS you can have per drive, how many IOPS on your server. You're capped on throughput. Bursting is a new thing that Microsoft has offered on the premium disks that allows you for 30 minutes at a time, you can exceed those caps, and then they slowly rebuild over time when you're going underneath the threshold. This is really important. So maybe, let's say that you have maybe a data warehouse environment or something like that, and you're doing some sort of like an incremental or full refresh of your data warehouse. So during that refresh, maybe it'll fit into that 30-minute period of time, and then the rest of the time your data warehouse is really quiet. So you can have that really good performance for that short period of time, and the rest of the time it just works out. It rebuilds. Just something to keep in mind. But as I said before, when we were talking all about the Tempdb, is that even when I put Tempdb onto a premium SSD, I still was having problems with latency. And I feel confident that I went through and analyzed it from a lot of different directions, and there wasn't anything wrong there. It just was not giving me the latency that I expected. Until finally, UltraDisk came out. UltraDisk are pretty neat. It's a brand new release. It's kind of limited. They're only offered in a couple different regions so far in the Azure world, but I was talking to the program manager, and apparently they're going to be general availability in about 4 to 6 months. They're expensive, but I did a little bit of limited testing on it, and they are really giving you that performance that you need. And one of the important parts is that not only are they giving the performance, they are expensive, but here's what the problem is with premium disks. So if you look right here at this chart right here, you can see the different sizes. So we have P4s, whoops. So we have P4 disks, 32 gigabytes in size, IOPS, 120 per disk, throughput, 25 megabytes per second. And then you look here at the P6, it's 64 gigs, 240, 50. But then we go here to the P10, so we have 128 gigs in size. And notice that the IOPS are a little bit more. It's double plus 10%, or not quite 10%. The important thing is, as you watch this chart, it's a little bit more. Now, unfortunately, I found in some of the production environments that I've worked in that you had to go all the way up here to the P30 in order to get the performance that you expected, that you needed for your environment. Now, but I didn't need that much space. I had to do this in order to get my logs on my SQL Server databases to work properly. But I didn't need it. I didn't need a whole terabyte of size. I only needed probably like maybe 128 gig. But the problem is look at the difference here. So you literally will ram your head up against the ceiling right here. So when I was using just a P10, it was hammered at 500 IOPS constantly. It could not go any faster. So once I moved it up to a faster disk, all of a sudden my databases had room to stretch their legs. Before, they were constrained into this tiny little box. There was no room. So this is the biggest fallacy of premium SSD, is that you have to spend all this money and buy all this space that you don't really need just to get the performance that you expect. Once again, Microsoft is giving you a great service, and you can pay to get the performance you want, but they're not going to give you anything more than you're expecting. This is why UltraDisks are kind of interesting. So here, instead of worrying about having to get these huge disks in order to get the performance right out of the gate, tiny little disk, 4 gigabytes, you can have an IOPS range of up to 1200. When we go back to looking at the last one, you see here, you had to get up to, right here, you had to do a 256 gig drive just to get up to 1100. Right here, a 4 gigabyte drive, you get up to 1200 IOPS range. IOPS are incredibly important in Azure. Don't mistake that don't ever forget that. Going all the way up here, and I did not show some of the really huge sizes, but their limitation is I think you can go up to 64 terabytes in a drive size. And you can go, I know the plan is to be able to do 160,000 IOPS as needed. Now, you are going to pay a veritable fortune for that. But when you think about the cost, maybe it's not so bad. So just for information right here, this P30 right here was going to cost you $122 a month in the West US 2 data center, which is one of the cheapest ones. I believe Brazil is something more like 230 as you go around the country. So overall, it's still going to be a cheaper option, but it seems a little bit silly. But then again, who can complain about having enough space? Ultra disks are expensive. So when we look at this one right here, so we've got our 32 gigabyte drive here. So they are charging you, the way that the design for the Ultra disk works is that they're charging you for the size provision, the IOPS that you provision, and the throughput range. So for example here, on this 32 gig drive, you get charged $3.77 a month for the size provision. No big deal. But for the IOPS provisioning, if you were to provision it at a max of 8,000 IOPS, it would cost you $391 per month for the IOPS provisioning. And if you want to have a throughput provisioning of 1,000 megabytes per second, it's going to cost you $986. So it's about $1,300 a month for a really, really small drive. But maybe you don't need, if you look at it, you don't need to have high IOPS and high throughput, because the truth is, based on the 256K packets that are coming through, you just can't do that many IOPS. So this is why it gets back to doing some prior planning. You want to talk to your business, you want to look at the type of application you're moving into Azure, and then you want to look at it. So if you're doing a data warehouse, maybe you need a lot more throughput because you're going to be bulk loading a ton of data. But if you're doing your typical OLTP type of database, then you're going to need the IOPS, but you could crank down the throughput, and maybe you only need a tiny amount of throughput because it's not going to really matter that much. So this, again, do your research, read the documentations, talk to gold partners like Pragmatic Works. I mean, all these things are important, but there's a lot of resources out there that can help you make that right decision. That's the most important thing, is I want you to have a good experience when you move into Azure, because I don't want you to have this experience right here. Using the typical catio, this is my analogy for being in your classic data center. So you're going to pay in a data center, you're going to pay so much per month, and you're pretty much going to be able to stretch your legs within a certain boundaries. They're not going to quibble about, they're not going to get you on per transaction usually. You're going to, and you may have some noisy or busy neighbors, but overall you're going to have a lot of room to grow in. While the difference in Azure, you pay for the size of the box, and that's the box you get. There's no wiggle room unless you start paying more. Again, Microsoft is providing a great service, and they're providing you a ton of redundancy. Part of the limitations they're doing this is that they have to sacrifice latency for performance, or I mean for redundancy. They're making sure, they're sacrificing performance for redundancy. They're making sure that you're going to have a quality product, and they're giving you those guarantees that they're going to be able to restore your data. You're not going to lose anything. So I understand that we just spent a lot of time talking about storage, and there's a lot more information out there. But let's just recap a little bit right here for your storage. Main thing is that you want to plan out your storage ahead of time and have it ready. Think about it. Maybe this is the opportunity. Maybe you've been playing games where you don't have enough space for all of your data growth. You don't have enough space for all your backups. Maybe you've got replication going, and you really need that space for your snapshots. Whatever your need may be, this will be an opportunity to think about that and size up a little bit so that your server is going to have lots of room to grow. One of the fairly new features, this is, I'm not sure exactly when this came out. All I know is that when I first started doing my research back in 2018, this was not a capability. So now, if you have your managed disk set up ahead of time, the restore of the VHD, your virtual hard drive from your on-prem server, can be restored directly into the new drives. When I was doing it, you had to restore the VHD, and it was created as an unmanaged disk, and then you had to create a managed disk, and then you had to do a downtime in order to move your drive into the new managed drive in order to get the performance. A couple extra steps. So now Microsoft is saying that you can just merely take your VHD from your original server and you can just copy right in, and you're going to be able to take advantage of the new drives. And the other thing is we need to talk about a little bit about the caching. So we went all the way, we talked about the different performance settings. And here we have a picture of one of my little test machines right here. As you can see right here, that I've set up, even though I could have done a better job in naming this data, this is my data drive here, this 10. And I've set its premium SSD drive, and it's read-only. This is going to be, again, for my asynchronous transactions. This is going to be read-only caching. Best practices recommended by Microsoft. This right here, again, should have been named, but this is my Tempdb. I was experimenting with Ultra disks. No caching for Tempdb. And then finally, for your log drive, no caching as well. You're going to see that your OS drive by default is going to have read-write caching. And so as we go here, let's talk about availability sets for a little bit. Way back in the beginning on the pricing calculator, talked about regions. So you're probably not going to be the one who's going to be picking the data centers, but your infrastructure team should have already picked a data center, or rather picked a region that is going to be close to you and your users. There is a difference. I've done some experimentation. I live on the West Coast again, and performance is better when I connect to the West US 2 data center for some reason. When I've done some testing in the East US data center, East US region, it's not horrible, but it's not as good. You can definitely tell that there's a bit of performance. Again, work with your infrastructure team. I mean, there's no reason why you wouldn't pick a data center as close to your users unless there's some specific reason that was only available in that data center. You will run into issues where they have, Microsoft has capacity issues. So you may have to work with Microsoft and make sure that you're able to get your set of your Azure tenant in the right place for you. Availability sets. This is how Microsoft is guaranteeing you a certain SLA. If you have a single VM, you are going to have a 99.9 SLA, a single 9 or a 3 nines uptime. If you were to set up 2 or more Azure VMs in an availability set, now this is going to be in the local data center. So they're all going to be in the same data center, but they're all going to be on different server racks. By doing that, Microsoft is guaranteeing you're going to have a 99.95 uptime. Why would you want to do this? Pay a little bit extra to make sure that you have that redundancy. You can guarantee that users. And then finally, availability zones. So this is talking about where you're going cross-regional. So you're doing this to guarantee an uptime in case there was some sort of a natural disaster. Maybe a data center got flooded or a hurricane. These things happen. So by doing this, that means that all of your data and your VMs are going to be replicated in a different region, which if the original data center were to go down, you're still going to be able to guarantee, you're still going to be able to access it. If you have 2 or more Azure VMs in an availability zones, you're going to have a 99.99 uptime. Networking, horribly important. By default, your Azure tenant is not going to have any ports open. And that's important for security. So this is a chance to work with your infrastructure team, work with your networking team. You want to set up your network security groups. This is where you're going to be poking holes in order to allow the ports for your applications to get through. Since we're talking about SQL Server, obviously you're going to need 1433. That's the default SQL Server TCP port. If for some reason you want to use a different port for SQL Server, which is can be used for security, then you need to make sure that that port is available as well. If you're using named instances, this one's a little bit tricky. You have to have 1434 UDP open. So that's if you're going to do MS SQL Server / MySQL Server 1. That's going to be your named instance. Analysis services. By default, you need 2383 TCP and UDP open, and that also can be changed. What can't be changed is 2382, which is for if you had a named instance for your analysis services. You have to keep that in mind. 135 for integration services, even though you probably should be using Azure Data Factory, and then port 80 for SSRS. You know, by default, SSRS is looking on port 80 or 443. Anyway, you want to keep those ports open. But these are just the ones for SQL Server. What are you using for your data warehousing application? What are you using for your reporting application? What is your application using in general? Each one of those probably has a port, and it's probably more than one port, depending on how the application works. So you need to make sure that you find out what these ports are. This working with your business, working with the vendor, working with infrastructure, and make sure that those ports are open before you go live on that new server in the cloud. Again, I want you to have a good experience when you get up there. So we've talked about a lot of stuff here. Let's go over the different points again. Use a good sized VM. Go back to the business. Look at what you have in place right now. Make sure that you are sizing appropriately for what the current expected performance is. And then maybe think about beefing it up by 20%. This is an opportunity to allow for growth. Set it up now, because downtimes can be very precious in environments. Some companies are pretty easy about downtimes. A lot of companies are not. And maybe you can only get a good downtime, the type of downtime you need to do for this, maybe you can only get that kind of downtime once a year or once a quarter. Make the most out of it. Take the time, do the planning, make sure that you have the right server waiting for you. Think about your regions. Plan your region is going to be close to your users and your environment. If you have a global environment, it's going to probably work just fine. Microsoft has given you good performance no matter what data center. But this is an opportunity to think about this. Think about what sort of redundancy you want to have. This is your DR situation where you have availability sets and availability zones. Important stuff. There's a lot of detail out there. We can certainly go over and find links for that if you want to look at more detail on that. Plan out your disk layout. None of the stuff that you learned about SQL Server disk layout has changed. You still want to have a separate disk for logs, you want to have a separate disk for data, and you want to have a separate disk for Tempdb. All these are important. Each one has a setting. Learn about the storage options in Azure. Don't be scared away by all the different choices. Take some time, read about it. You're gonna have a better experience if you do that. Don't forget to set your caching on your disk. I mean, really, the caching just gets down to setting read-only on your data drive. But by doing that, that's going to improve the performance on your data drive, which again is 95% of the transactions on your database. A new feature, again, if you're using the managed disk, the restore of your on-prem server can be restored directly in new managed disk. So that's great. That's going to save you some time by doing that. Otherwise, the disk can be restored as unmanaged disks. They're still usable. You can restore your VHDs into unmanaged disks, and everything's going to work just fine. But you may decide that you've spent the time to do the research on managed disks, you want to set them up, you want to move all of your data into the managed disk. So that's what you want to do. As I said, if you are restoring to unmanaged disks and you have your managed disk ready, and you can move your data files into there. Set up the Tempdb boot script. A little bit scary steps, but again, what you're doing is that you set it in a managed disk or managed task on your server. So when your server reboots, it's going to automatically check and see if that Tempdb is empty. If it is, it's going to go and create your Tempdb data files and your log files. It's going to tell SQL Server, this is where your Tempdb is, and then it's going to start SQL Server, and that's all there is to it. And I am telling you that you're going to have better performance by setting up on that dedicated temp drive. And then finally, making sure your right ports are open depending on your network security requirements. It is an easy step to forget, but by working with your infrastructure team in the business, you're going to have a much better experience by doing that. The last thing you want for your users is after you've done this huge downtime and you've migrated everything into the cloud, and then nothing works. They can't connect. And guess who looks silly? So recapping what we learned here. Again, SQL Server best practices do work in Azure. All the same concepts, because all you're doing is you're connecting to a Windows or Linux server. We're not even talking about Linux, but still, that's running SQL Server. All of the disk layout, file layout, all these practices work just the same in Azure. Planning your storage makes a big difference. Go back, look at the links, learn about Azure storage options. All that information is out there. It's very important. I want you to go look. You're going to improve your education. You're going to get a little bit of view into the Azure world. And finally, remember, Azure is going to give you exactly what you pay for, no more, because you don't want to have this experience. We want you to buy the box that's big enough so that your database has room to move around. Azure is a great opportunity. It's a great offering. It provides a solid environment for companies with top-notch service and features. They have great support. The monitoring is great. All these features are there. But if you need help, you can always work with Pragmatics. They'd be more than happy to help you size up your Azure environment. there's a lot of people out there who can help you. You're not doing this all by yourself. That's one of the reasons I wanted to do this webinar, so that people understood that there were options out there to help you moving forward. So thank you very much for your time here, and I hope you enjoyed this presentation.
All right, awesome. Thank you so much, Michael, for jumping back on and getting this recorded for us. We really appreciate it.
Sure.
And as for the few people that are online, if you guys have any questions, please feel free to reach out to Michael or myself. This is the second part of our DBA Madness series. If you guys would like to join any of the rest of them, I will put the link in the email, as well as if you guys would love to learn anything about DBA, please feel free to reach out to us as well, and I will put the link in the email, in your email for that, as well as in the chat for that too as well. Thank you guys so much. I hope you guys have a good rest of your Tuesday, and thank you for joining. Have a great day.
Thank you, guys.